All right, so I'm going to go over some kinematics concepts. So keep in mind there's a few different quantities that we need to know the difference between. Well, I guess there's two different types of quantities, and this is just a good time to remind us. There's scalars and there's vectors. Remember, a scalar is a quantity that just has a magnitude, right? So how much of something, and there's no direction associated with it. A vector, on the other hand, has direction. So in the case of kinematics, we really care about the difference between, let's say, speed and distance. These are usually used to refer to scalars, whereas in like the vector sort of the vector quantities that are kind of analogous to these would be velocity and displacement. Notice that acceleration is also a vector. All right. So some basic definitions. This is a definition for average velocity. That's displacement over change in time. And the definition of average acceleration is change in velocity over change in time. And also keep in mind here that if we want to talk about instantaneous velocity and instantaneous acceleration, well, basically the definition is the same, but we're looking at a very, very, very short time interval in order to define what the instantaneous velocity and acceleration are. Okay, so also keep in mind, I just want to bring up uniform circular motion here. So let's say we have something in uniform circular motion, right? That object has a changing velocity, even though its speed is not changing. And that's because it has an acceleration that always points perpendicular to that velocity vector. All right, kinematics equations. So these are the kinematics equations that they give you on the equation sheet. And basically, you can only use them when acceleration of an object is constant. So in order to use the right equation, you basically have to pick the equation that has only the unknown that you want to solve for and not the other unknown. So for instance here, right, this one does not have any of the displacement quantities. So if you had all of these other quantities except for one, you would be able to use it to solve for that one quantity that you want. But right, if you had displacement, you might not want to use this equation because you can't use it. I guess it depends on, that's not necessarily true. It kind of depends on the situation. But as a general rule, right, you pick the equation with the knowns that you have and one unknown that is the unknown that you are looking for. Okay, so when you set up a kinematics question, basically you need to define which direction is positive and you need to choose where your origin is, right? So in the case of like a dropping ball, for example, you might choose to make the origin the starting place of the ball and call down the positive direction. And then you would want to plug in your quantities to the kinematics equations using that setup, right? And in this case, the acceleration due to gravity would be positive, right, because it's the same way as our axis. But you could take the same problem and instead set it up like this, right? If you wanted to, you could put the origin at the bottom and make up positive, and then the ball would be starting at some positive position. It's really just up to you. Okay, graph interpretation. So remember, if you have a position versus time graph, the slope of different points on that graph gives you the instantaneous velocity of that object at each of those times. So for example here, right, we start out with a steep slope and the steepness of that slope decreases, indicating that the velocity is decreasing. At the highest point, the slope is 0, which is where the velocity hits 0. And the slope here becomes negative, which means that, and steeper, steeper, steeper negative, meaning the velocity is increasing in the negative direction. Notice also that the slope of the velocity versus time graph gives us the acceleration here, right? So here the velocity versus time graph has a straight and negative slope, meaning the acceleration has a constant negative value. And I just assumed, right, I looked at this and I assumed that we have a situation with constant acceleration, right? So that's something that I just assumed when I drew these. And most of the time, if you're doing graph interpretations, that will be true. Okay, using area. So if you want to go backwards, right, so if you have this and you want to get information about this, or if you have acceleration and you want to get information about velocity, you can use the areas of your graphs. So for example here, right, if you want to get the area under this velocity versus time graph, the area between whatever two times you choose gives you the displacement of the object over that time interval. And this makes sense, right? Because if an object is traveling faster over a given time interval, the area will be bigger, and it will have gone farther during that time interval. Similarly, you can use the area under an acceleration versus time graph to get an object's change in velocity, right? So, and for both of these, this is true, right? If the area is under this line, then it's negative. Excuse me. And if it's over the line, then the change in velocity is positive. So over this whole interval that I drew here from t1 to t2, this object will have had a negative change in velocity because there's more area here than there is there. All right, 2D kinematics. So remember, in 2D kinematics, we have to think separately about movement of an object in the x direction and the y direction. And this means often we're going to start out by breaking up vector components. You might be actually using the components to build the magnitude of the vector, the velocity vector, that would just be the speed. But in a lot of situations, you start with the speed and you have to break it apart. So remember, we can use trigonometry to do that. The x component would be this times cosine theta. The y component would be this times sine theta. And the two components are related to the magnitude of the velocity vector through the Pythagorean theorem. All right, so this squared plus this squared should equal that squared. Also remember that for projectile motion, in the horizontal direction, the velocity is always constant. So you can just straight up use this equation because this is a constant value, right? The acceleration is 0. In the vertical direction, the acceleration will always be equal to plus or minus g, right? Just depending on which direction you decide to make positive or negative. And you have to think separately about the motion in the x and y directions, right? That means that you're going to have to set up different equations for the x motion and the y motion, using this equation always for the x direction. But in the y direction, right, you will want to use the kinematics equations because it has acceleration in that direction. And I think, here we go. So looking a little bit at the motion of a projectile, right? So if you have a projectile that's fired into the air, the red indicates the velocity, the total velocity, and these blue vectors represent x and y components. So the x component of the velocity vectors, they should always be the same, right? This is excluding air drag. And in the y direction, the velocity is decreasing, and it should decrease at 9.81 meters per second squared. And then at the highest point, there's no vertical velocity, and then the vertical velocity increases. Cool. And I think that's about it for kinematics.